Hello, in this video we are going to discuss about how to convert CNF to GNF, but before going for that, let's take a look on what is context-free grammar or CFG. A grammar is said to be a context-free when its production rules can be applied regardless of the context of a non-terminal. That is, no matter which symbols surround it, the single non-terminal on the left-hand side can always be replaced by the right-hand side. Now let's see what is Chomsky normal form. A context-free grammar is said to be in Chomsky normal form if all productions are in the following form, that is A goes BC or A goes alpha, where A, B and C are non-terminal symbols whereas alpha is a terminal symbol. Now let's take example for Chomsky normal form. Suppose we have a grammar, let's say S goes ASB and S goes AB, which is a CFG. Then for every terminal symbol, we introduce a new non-terminal symbol. That is A, the small a becomes A and B becomes B. To get S goes ASB. But still it is not in CNF form. Now here S we obtain this S goes ASB is not following the rule for CNF since we need only two non-terminals on the RHS. We assume SP as a new non-terminal set D, making it as S goes AD. Thus we have CFG in CNF as S goes AD, S goes AB. Now let's see what is GNF. A context-free grammar is said to be in GNF if all productions are in the following form, that is A goes alpha X, where A is a non-terminal symbol, alpha is a terminal symbol and X is a sequence of non-terminal symbols. It may be empty. Now let's see the algorithm which we are going to follow in order to convert a grammar into GNF. Step 1. If the start symbol S occurs on some right side, create a new start symbol S dash and a new production S dash goes S. Step 2. Remove null productions. Step 3. Remove the unit productions. Step 4. Remove all direct and indirect left recursion. And finally step 5. Do proper substitution of productions to convert it into the proper form of GNF.
Now let us look at example of left recursion. Here we have a production that gives A, terminal A and B and C. Now what you do is you copy all the terminal symbols as it is and add an extra symbol like B we have taken to those symbols. This B will give the production of that one that had a terminal symbol along with a non-terminal symbol along with B itself. This is one of the way of doing left recursion. We take the example of converting into GNF with this question. Now, as specified earlier in the algorithm, what we need to do is do it by step. The first step is we have to see if it's in CNF. Here, none of all the three productions are in CNF, so we continue. Now, relabeling of variables is to be done. You can take any variable you want. We have converted S with A1, X with A2, A with A3 and B with A4. After relabeling, you can see that all the productions which were of non-terminal form have been converted into A1, A2, A3 and A4. This is the question that we now need to solve. The third part of the algorithm stated that we have to check if any of the productions do not form under these three rules, which are basically if the right side of the production has any subscript whose value is less than that of the left side, then we have a problem and we have to change it. Similarly, we have to do it even when the production value of the non-terminal symbol on the left side and the right side are different. In our question, this A4 gives A1 A4 has been identified as the line that gives that problem, because 1, as you can see, is less than 4. Therefore, we have to eliminate A1 and we will use the substitution rule, which means that in the production A1 gives A2 A3 and A4 A4, we will put the value of A4 here. Therefore, we will have A4 gives A2 A3 A4 and A4 A4 A4, and of course the B will be carried down. The above two production still do not conform to any of the types in step 3. Now, if we substitute A2 with B, the earlier production will be B A3 A4 and of course A4 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 along with B. Still, we have to remove the left recursion from A4 gives A4 A4 A4, because here too the value on the left side, that is 4, is not greater than all the values on the right side. To do this, as we earlier showed, we have to use another variable, in this case Z. So we just copy all the productions that have a terminal symbol, in our case BA3, A4 and B. We add the symbol Z with it to get our A4 production. Now the value of Z will be the non-terminal production along with Z added to it. This is our answer at this stage, where we are still not finished. What we need to do is change the value of A1 so that this also conforms to the GNF. To do this, we have to substitute A2 and A4 to convert it to GNF. A2 will of course be converted to B as earlier stated, and the value of A4 we solved just earlier. This is our final answer. Thank you for watching, and now look out for the second example for GNF conversion.
Let us look at another example to convert the Chomsky normal form into GNF. In this example, there are three rules. A1 implies A2 A3, A2 implies A3 A1 or B, and A3 implies A1 A2 or A. To convert it into GNF, the step 1 is that it should follow the ordering rule. That is, if AI implies AJ gamma, then J should be greater than I. Whereas in this case, this rule follows ordering rule, this rule follows ordering rule, but the third rule, which is A3 implies A1 A2, does not follow ordering rule. In this rule, ordering rule is violated. So we have to change only this rule. We have to change this rule by substituting the value of A1 from here and again substituting the value of A2 from here, so that the ordering rule is not violated. So let us follow the procedure. A3 implies A1 A2 or A. Using rule A1 implies A2 A3, in this we get A3 implies A2 A3 A2. But the ordering rule is still violated in this rule, as 2 is less than 3. So we again use A2 implies A3 A1 in this rule. After substituting the value of A2 implies A3 A1 in this, we get A3 implies A3 A1 A3 A2, B A3 A2 and A. In this rule, ordering rule is not violated. So our step 1 is done. Now let us come to step 2, that is removing the left recursion from this rule. In this rule left recursion occurs as this rule is of the form A implies A alpha comma beta, where alpha is A1 A3 A2 and beta are B A3 A2 A, B A3 A2 and A. So to remove all the left recursion, we have to follow these two rules. That is, we have to introduce new productions for A, and we have to also introduce a new non-terminal symbol B and its productions of the form this. Eliminating the left recursion by introducing a new non-terminal symbol B3. Here introducing new rules for A3, as in this case our A is A3, so A implies beta B, where beta are these two. So beta B A3 A2, and what is B? B is B3 here. So beta B comma and beta. So this is our new A3 rule. Now following the second step, B implies alpha beta. Our alpha here is A1 A3 A2. So B implies alpha beta and alpha. This is alpha beta, not alpha beta, alpha B and alpha, alpha B and alpha. So now we have removed left recursion from our example. So now our A3 rule has passed both the steps, step 1 and step 2. Now since all the A3 rule, which is this, all the productions of A3 rules start with the non-terminal, start with the terminal. So substituting the value of A3 in A1, A2 and A3. By substituting the value of A3 in A2, we get A2 this. In A2 also, all the symbols start with the terminal. Now substituting the value of A2, A3 in A1, all the productions of A1 start with a terminal. And now substituting the value of A1, A2 and A3 in B3, all the productions of B3 also start with the terminal. So we have converted this is our final solution, and we have converted our CNF into GNF.